Hi students, welcome back to the Google Classroom of Plus One Statistics, Chapter 4, Presentation of Data. Good morning children, how are you? I hope all of you are safe and fine there at home. In the last class, we have learnt about the diagrammatic representation of data. It includes three types of diagrams. Which are they? Geometric diagram, frequency diagram and arithmetic line graph. Geometric diagram includes bar diagram and pie diagram. Then bar diagram can be also classified into simple bar diagram, multiple bar diagram and component bar diagram. Today we will focus on the frequency diagram. The frequency diagram consists of histogram, frequency curve, frequency polygon and ogives.
Our next topic is graphs. Data in the form of grouped frequency distributions are generally represented by frequency diagrams like histogram, frequency polygon, frequency curve and ogives. So first one is histogram. A histogram is a two-dimensional diagram. A histogram is a two-dimensional diagram. It is a set of rectangles with a base as intervals between class boundaries and with areas proportional to the class frequency. So here histogram represented by a set of rectangular bars. Variables is taken along the x-axis and frequency along the y-axis. This is the picture of histogram. With the class intervals as base, rectangles with height proportional to class frequency are drawn. The set of rectangular bars so obtained gives histogram. The total area of the rectangles in a histogram represent the total frequency. If the frequency distribution has inclusive class intervals, they should be converted into exclusive type. We have already learned about this inclusive class interval and exclusive class interval. Mode of the distribution can be obtained from the histogram. That means from the highest rectangular bar. So children, we mark class intervals along the x-axis and the areas proportional to the class frequency along the y-axis. This is x-axis and this is y-axis. So class interval, you should mark class interval here in the x-axis and frequency in the y-axis. Children, look at this picture. This is a histogram. So here the class interval 145 to 150, 150 to 155, 155 to 160, 160 to 165, 165 to 170, 170 to 175. Then frequency 2, 5, 9, 9, 4, 1. So children, you should mark class intervals along this x-axis. Like 145 to 150, 150 to 155, like this. Then children, what is the frequency of our first class 145 to 152? So you have to draw a rectangular bar like this along the frequency of 2. Okay, then next one 5. So draw like this. Draw a rectangular bar like this. Then next one, next two classes have the same frequency 9 and 9. So you have to draw the rectangular bar like this 9 and 9. Then next one 4 and last one 1. So this is the histogram. A histogram looks similar to a bar diagram, but there are more differences than similarities between the two than it may appear at the first impression. We can have a bar diagram both for discrete and continuous variables, but histogram is drawn only for a continuous variable. So children, how can we obtain the mode of the distribution from the histogram? So mode of the distribution can be obtained from the histogram. So first we have to draw the histogram as per the data. Then we have to draw like this and we get the mode 35. That means mode of the distribution can be obtained from the histogram, from the highest rectangular bar. So this histogram gives the value of the mode of the frequency distribution graphically by using this method, and the x coordinate of the dotted vertical line gives the mode. So here the x coordinate is 35. So here the mode is 35. Next one, frequency polygon. Variables is taken along the x-axis and frequencies along the y-axis. Class frequencies are plotted against the class mid values, and then these points are joined by straight line. A frequency polygon is a plane bounded by straight lines, usually 4 or more lines. So the figure so obtained is the frequency polygon. Total area under frequency curve represents the total frequency. This is the picture of frequency polygon. By using straight lines, we have to construct this frequency polygon from the data. Frequency polygon is an alternative to histogram and is also derived from histogram itself. The simplest method of drawing a frequency polygon is to join the midpoints of the top side of the consecutive rectangles of the histogram. It leaves us with the two ends away from the baseline, denying the calculation of the total area under the curve. So children, our first class 5,000 to 10,000. So this is the first rectangular bar or the first one. So take the midpoint. Then children, what is the frequency of the second class? 10,000 to 15,000? 53. So you have to mark here 53. This is the midpoint. And next one, third class 15,000 to 20,000. Frequency 21. So you have to mark here, and this is the midpoint of the histogram. Then next one, 20,000 to 25,000. 18 is the frequency. You have to mark here, and this is the midpoint of the class. Then next one, 25,000 to 30,000. Frequency 3. 25 to 30,000. Then draw the histogram and mark the midpoint of this histogram. And join all these midpoints with straight line. Okay. Next one is frequency curve. The frequency curve is obtained by drawing a smooth freehand curve passing through the points of the frequency polygon as closely as possible. It may not necessarily pass through all the points of the frequency polygon, but it passes through them as closely as possible. So, children, in short, variables is taken along the x-axis and frequencies along y-axis, as is just as same as in our frequency polygon. Frequencies are plotted against the class mid values, and then these points are joined by a smooth curve. Frequency polygon, we have to join all these points by straight line, but in frequency curve, we have to join the midpoints of each histogram by a smooth curve. Don't use scales or straight lines. The curve so obtained is the frequency curve. Total area under the frequency curve represents total frequency, just as the frequency polygon. Children, look at this frequency curve. These are the midpoints of histogram, and we have to join all these points, all these midpoints of the histogram through a smooth curve. Okay.
Let us conclude today's session by recollecting all the concepts.
Children, what do you mean by a histogram? A histogram is a two-dimensional diagram. It is a set of rectangles with base as the intervals between class boundaries and with areas proportional to the class frequency. The total areas of the rectangles in a histogram represent total frequency, and the mode of the distribution can be obtained from the histogram, that means from the highest rectangular bar. Then we have learned frequency polygon. A frequency polygon is a plane bounded by straight line, usually 4 or more lines. Frequency polygon is an alternative to histogram and is also derived from histogram itself. Next one, frequency curve. The frequency curve is obtained by drawing a smooth freehand curve passing through the points of the frequency polygon as closely as possible. So we have to join the midpoints of the frequency polygon by a smooth curve.
So children, please note that the corresponding URL, notes of the lesson and test paper are also attached along with this video. Make use of all these available resources, study well and attend the test paper without fail. Thank you.